In this video, we're going to real quickly talk about diagonal matrices, which are something that we will be interested in later on in this course. So I'm going to just tell you what a diagonal matrix is. It's the type of matrix that it's only got non-zero entries along its main diagonal, and it's a square matrix. So the definition would be it's diagonal if the ijth entry is 0 whenever I and j are not the same. Because if I and j are the same, we would be working down the main diagonal. First row, first column, second row, second column, and that's the main diagonal. Where the ones are in the identity matrix. So this would mean that the identity matrix is an example of a diagonal matrix, but for a different example, you can see this one right here. This matrix D 1 0 0 0 2 0 0 0 negative 3 is a diagonal matrix because I have non-zero along the main diagonal and 0 everywhere off the main diagonal. Now at this point in the course, what we're interested in is, well, obviously identifying what types of matrices are diagonal, but also taking powers of them. Okay, because I think that's kind of a preview of why we're interested in them in the first place. Okay, you take powers of regular matrices and it involves a lot of computation. It's very painstaking, especially for powers higher than 2, right? It's just a lot of matrix multiplication. But we're going to look and we're going to see that taking powers of diagonal matrices is actually quite easy. So what we're going to do is look at d to the 2 power. Well, say d to the 2 is going to be d times d, but I'm going to take that kind of column perspective of the multiplication here and say, all right, I'm just thinking about it first. Do I multiply it against 1 0 0? So this is going to be equal to, well, when I multiply this matrix by 1 0 0, I'm just copying the first column. So that's 1 0 0. Then when I multiply by 0 2 0, I'm taking none of the first, 2 of the middle column, and none of the third. So it'll be 0 4 0. And then when I multiply 0 0 negative 3, okay, so that would be d squared. Well, I'm going to be taking none of the first column, none of the second column, and negative 3 of the third column, so that's going to give me 0 0 9. And maybe you see what I'm trying to get you to see here, and you're like, okay, now I know how to take powers of diagonal matrices. But if not, let's find d to the third. Now, if we want to find d to the 3, we could find that by taking d squared and multiplying in another factor of d. And so if I take that same perspective, I'm going to get, okay, well, the first column be just copy the first column, none of the second, none of the third. Okay, in the middle I'd have, okay, double the middle column, so 0 8 0. And then for the last column, negative 3 of the third column, so 0 0 negative 27. And if you didn't see it before, now it's like, okay, it's just the powers of the entries along that main diagonal. If we're asked for the nth power of d, we could find that by just taking the nth power of each of the entries on the main diagonal and saying, okay, well, any power of 1 is 1, but then 2 to the n and negative 3 to the n. Okay, at this point, that's all I need you to know about diagonal matrices. There's going to be a problem on tonight's homework and then maybe on a future quiz that you know, would go a lot faster if you just knew this special fact about diagonal matrices powers. Okay, so that's going to be all for this video. Thanks for watching.